Hello, namaste, good evening. Welcome to this UPS seminar, a webinar on engineering the future to help people who want to explore their engineering options for the future education and how to make their appropriate decisions. I am Gurvinder Virk, and I am the Dean of Engineering at UPS since January just gone. I am an electrical engineer who has specialized in control and robotic engineering, and have been a professor in control at several places since 1995. In particular, I have been teaching at departments of electrical engineering, mechanical engineering, computer science, and technology. My experience has been in UK most of the time where I grew up, in New Zealand where I spent 5 years, and Sweden where I spent 6 years, Germany where I worked for 1 year, and then various visiting professorships in France, China, and in India. In particular, in India, I was involved with IIT Ropa in mechanical engineering, as well as helping their industrial collaborations and entrepreneurships. Since I've been living in the UK, I've only recently come to India in 2019 to set up a robotics engineering company in Mohali, Punjab. The company is still, in fact, running, but UPS invited me to join them as Dean of Engineering this January, and I'm delighted to be here and delighted to be heading this webinar. And I'm joined by my distinguished colleague, Professor Patra, who's the Dean of Computer Science. He also has a very illustrious career, mainly in the US, but I'll let him present himself. Priyadarsan, why don't you introduce yourself?
Thank you. Good evening and a warm welcome. Namaskar. My name is Priyadarsan Patra. I'm a professor of computer science and engineering, and I head the School of Computer Sciences at UPES. I, like Professor Virk here, joined very recently, end of January, as a matter of fact. I have been a chip designer, a chip architect for many, many years. I was heading global teams of Intel Corporation, and which were in about 4 different continents and maybe 8 different countries. So it's I have had interesting experience both from the pure engineering side of Intel, as well as research, Intel research labs. You hear about the microprocessors either in your cell phones or in the servers or desktops and laptops. Some of it might have some of my designs in there. Anyhow, I also have been teaching as a professor. I have also led other universities as a dean, particularly the Xavier University. And I'm truly delighted to be here talking with you all. And as Professor Virk said, we'll be trying to answer some of the basic but important questions that students and parents ask before they make their best choice of an institution and the discipline of study. So I will field the first question to Professor Virk. The question that we have is, what problems the engineers of tomorrow are expected to face and hence wish to solve?
The problems are immense, as we all know. They have been for many years. They're growing even more complex. They're becoming more specialized. And so the scene in India is the same as the scene everywhere. So I think we live in a global world. So we cannot be just handling what's happening in India. We have to be looking totally global. So what I would sort of say is, right now, engineering is becoming so specialized that we have to produce specialist engineers who go deep rather than wide and have a lot of skills in their chosen career.
Absolutely, I completely agree, and I'll give a little bit of a shape or smell to that in terms of computer sciences and engineering.
Yep, sure.
We are growing more connected than ever before, as a global society, we have been, realized we have been enjoying many fruits of the engineering and computers over the years. But still, millions of people in our world today still face water, energy, and food shortages. The divide between digital haves and the digital have-nots have been deep, and they have not been bridged. We face some of the most turbulent times in our history. For example, we are facing even cyber warfares. Very recently, we also heard how explosions in, for example, Iran, nuclear facilities. Climate change is another major problem that we are facing today as a humanity, as a society, where we have extended droughts, cyclones, heat waves, even ice bursts in the Himalayas. For example, recently Uttarakhand faced that. So our health remains still under threat. We are now facing the pandemic for an extended period of time. So these are the major problems that our society, our humanity faces, and we as engineers and scientists, as we are here hopefully to solve those problems.
Absolutely. I guess these are what we would call real world problems. So, and the real world problems are going to be with us forever. So at the moment, you've described some very important things happening to us, and we need our technology to try and help. And as we know, our colleagues did do many things for COVID, and they had some significant impact. What I'd like to maybe add is that since I came to India 2 years ago with my company, I started hiring graduates. I started hiring skilled people. I started hiring freshers. I started hiring even students. And what I learned was that they were very, very focused on theory. Theory, and more theory. And when I started asking them about some very basic engineering, it was clear that they had not been exposed to these even elementary engineering technology. So I became a little bit concerned that is this just the cohort that I'm meeting? But then after 2 years, it became a pattern that this is actually what is happening, that the students are not being trained or to be industry ready, as is claimed in many places. And we have to maybe try and change that. And as you and I have discussed this many times in the short periods, that this is in fact a challenge for UPS, and we will address this challenge. This is where we are going to go. We're going to create industry ready graduates and who are real world problem solvers. Correct?
Absolutely. I couldn't agree more. As a matter of fact, it is seen not just in the traditional engineering fields, but also in other fields, including computer science and computer engineering.
Yes.
As a matter of fact, that's why Professor Virk and I have been also creating visions where true spirit of engineering and computer science will come in. For example, I know you are working on the idea of a robotics program that will have many disciplines involved. Similarly, I am envisioning the idea of a smart campus that would have tremendous number of projects that we could do that involves everybody, including our adjoining villages, as a matter of fact, the society in general, in addition to the disciplines we represent. So yes, I agree.
Well, you mentioned robotics. As you know, robotics is a passion of mine, so I'll spend a few moments just talking a little bit about that, because this is something I want to bring to UPS, and I hope to India itself. Robotics has been in my life since 1995, so 25 years. I have been spending in lots and lots of robots have been developed. And robotics generally is seen as a major disruptive technology in this century, more or less like what the car was, the automobile was in the last century. But what I can tell you is that I would rather not, when I say I'm a robotic engineer, I say that after about 30 years experience. It's so difficult now to produce a robotic engineer Robotics is built on the pillars of mechanical engineering, on the pillars of electrical engineering, and computer science, software engineering. So without these three disciplines, we cannot have world-class robots. So there's no way that if I'm saying I'm an electrical engineer, I can make the kind of robots that I want. I have to, and I must work with mechanical engineering colleagues, computer scientists, computer engineers, if we're going to realize the kind of technologies that the world needs. Because as I said at the beginning, engineering generally is moving into a very, very sophisticated levels. We cannot, after 3 or 4 years, expect a graduate to be skilled at this level. We have to specialize, have to take the depth rather than the width if we're going to understand and produce the core domains that are needed. And so that's what I think we want to do. And I think we are aligned with your chip technology, with your software technologies. And we need the third pillar, the mechanical engineer, who will then give that mechanical engineering expertise. And then we will have the pillars for robotics. What do you think?
Absolutely. As a matter of fact, the engineering fields that you mentioned and the computer science and computer engineering today are actually joined in the hip.
Mm-hmm.
They absolutely need to operate together interdisciplinarily.
Right.
And here is our opportunity for working together, and also present that opportunity to the students and the scholars who will be joining UPS.
Right.
That's the wonderful thing,
Right.
that it's not only just for our faculty or researchers here, but it is truly for our students and scholars, PhD scholars who will be joining. So I wanted to add to this, saying that, yes, I have been a chip head. And of course, I also have worked in the field of AI from the perspective of architecture and algorithms, which is a little bit different, still using some of the traditional chips or some of these AI chips that we are recently making. So we are combining, for example, their true hardware engineering from the perspective of computer chips, as well as computer science and algorithms and programming. So that is where the innovation, and then it needs to extend out, like you mentioned, to robotics. That is actually a common field of common interest, that, as you pointed out rightly.
Right.
And also we could say that computation is to biology what calculus is to physics. What, in other words, computation, the language of computation is fundamental to describing, storing, transforming information. And as a matter of fact, we can view our body as a biological computer.
Absolutely.
And our RNA and DNA, those are the algorithms that are truly running. So as a matter of fact, there is a tremendous interconnectedness here.
Right.
And we are hoping that we will bring that sort of a thing to India and our university in particular.
Right.
And of course, we'll be joining hands with others. We'll be having a lot of collaborations and all that. But that's the passion and the technology that we wish to bring to UPS.
Right. Shall we just move a little bit further into maybe going into the core engineering domains and how these domains you think will solve these growing world problems? So maybe you can start.
Sure. What I was asked is what skill sets are necessary for a successful engineer, keeping the future in mind? That's basically what we're trying to answer a little bit. Okay. So, the fourth industrial revolution, some people say it IR 4.0 to be cute about it. So the fourth industrial revolution is characterized by the rise of cyber physical systems. That's where, again, I'm bringing in the connection between the cyber technologies and the physical technologies that, our engineering school, for example, brings in, where machines and robotics controlled by automation systems, which are equipped with AI and machine learning technologies, they are coming together, and we are at this cusp of the so-called age of knowledge, or the cognitive age, some people call. So here the real progresses that could be made, researches that could be made, are the interfaces of various disciplines. And new research is truly being created now at the interfaces. And I'm hoping, we can name several technologies. I mean, we can say AI, we can say cloud networking, edge networking, data science and big data. Bottom line is that, all these fields are now coming together and getting interwoven.
Correct.
What do you think?
I agree with that, and I would even elaborate that not only these technical areas, but even these non-technical areas, things like law, business, humanities, they are now being brought into various projects where technology is being used. Things like ethical issues are becoming important. Should we be applying technology in this way, and should we be doing something else? Like the concept of driverless cars, which has been in the news a lot, where we hear of when a driverless car kills somebody, who's liable? The guy who made the car, or the guy who programmed the car, or the guy who gave them the faulty vision camera, or what? And so these kind of ethical issues are now becoming important. So our engineers and our computer scientists need not just to be technocrats, but they need to be aware of these wider issues. And so that's why as we've discussed, that we will not be just collaborating with the schools of the technical areas, but the schools of law, the schools of design, the schools of business, and then our graduates need to be able to interface to those people as well, because their language is quite different from what we're teaching them. We're teaching them Laplace transforms, differential equations, and linearity, and all these technical terms, but these probably don't mean anything to the lawyers and so on. So we need to have a different communication channels. And I think in your computer science, you have also very, very formal methods of security, of hacking. You've mentioned fake news, all these kind of things. How do you now kind of extend to those kind of things?
Right. So UPS has been a innovative university in that context. We have created something called School for Life.
Correct.
As a matter of fact, School for Life is supposed to capture these notions where students can be creative and multidisciplinary at the same time. For example, we have started even a degree program, a master's program, that is BTech in computer science and engineering, but master's in law. So similarly in the health area, and I'm sure we have some with even engineering, various fields. So truly, this extension is by design. For example, our students, we expect all our incoming students now to have something called social internship. That is an innovation.
Absolutely.
And what does social internship bring? It brings our students closer to the community, understand their problems, then come back to the campus and try to solve them. And then give back to the society.
Absolutely.
So really, truly, that is the vision.
Absolutely. So this kind of balance between technology, non-technology, and the changing trends is clearly important. So our students will, of course, be educated with the latest current trends. These trends are going to change. They are changing all the time. And so we have to tell and teach our graduates that what they're going to learn is relevant now. And it's not going to be relevant in 3 years or even 2 years, perhaps, and certainly not relevant in 10 years. And so the School for Life is going to teach them this training that they must maintain.
The essential skills for life.
They've got to keep up to date. They've got to keep learning, and UPS, through the various things that we've talked about before, we will support them for 5 years after they graduate, and for as long as they want, through the alumni program that we have. So that is very important for any graduates who come to UPS, that you will be a UPS graduate, not just for the 3-4 years you're here, but for life, if you need our support, because that's how we are set up. We support our alumni for life, not just through the School for Life, but through the faculties as well. So that is very important. Shall we move on to the next one, Priyadarsan?
Sure, yeah.
The next question I got I don't know if you got the same, is what should one look for in an engineering institution? So do you want to start that? Or
Sure, yeah, I'll give a crack and
Cool.
you can take on. So, students and parents often care about employment, quality of education, and student experience. So I agree, I couldn't agree more, the things that
well, you have
even
children.
I as a parent,
children.
I have
Absolutely,
children.
I have children. I have 6 children.
Right. So looking at that perspective as a parent, and I was a student and you were a student at some point too.
Absolutely.
So from that perspective, what we are looking for is an engaging curriculum. We are looking for a highly qualified faculty and a good student to faculty ratio, right? And flexibility to choose some advanced and interesting topics to give outlets to our own creative urges and curiosity.
Right.
We also care about opportunities such as internship and research opportunities, projects and stuff. We also care about health and wellness and safety on campus, right? And infrastructure, infrastructure of a university. What extracurricular and extramural and co-curricular activities and clubs, etc., that are available, and what kind of career services, alumni network, etc., exist.
Sure.
So it's a number of things, but these are some of the important things that I, as a parent and as a student, I have cared for.
I think all of those things are important, Priyadarsan. I think you spotted. So they must be good in the discipline, clearly.
Right.
But the wider skills are even more important sometimes. So when you go to university, you want to meet a wide cohort of people, and being in a multidisciplinary university like UPS is very important. So you don't just kind of meet the electrical engineers or the computer engineers and you just become a sort of a blinkered individual.
Not monolithic or single dimensional.
So I think that's very important. So it's important to be meeting these wide skill sets. But having the good engineering labs is very important, and I can confidently and very proudly say that UP has got incredible engineering labs, probably in the top 5% in terms of India, in terms of quality, in terms of how much investment the university has made, in terms of teaching core engineering principles from all the areas. We have 6 engineering disciplines: electrical, mechanical, civil, petroleum, which was in fact the core starting department when the university was set up almost 20 years ago, and chemical engineering. So these are, and aerospace, by the way, as well. So these are very, very important disciplines of engineering, which require specialist labs. Aerospace, for example, requires a wind tunnel, very expensive piece of kit. The mechanical engineering requires very sophisticated quarter car models, so to vibrate how the car vibrates and so on. And electrical engineering needs very specialized equipment to make PCB boards and embedded circuits and the latest technologies. So we have all of these latest technologies, and we will be following the trends and keeping them up to date as grows. Right. What I think maybe engineering tends to be a male-dominated discipline ever since I've known it, but I can proudly say that UPS is trying to change that. We are trying to, we're not trying, we are offering scholarships for girls, which reduce the 20% scholarship fees to encourage girl students to participate in STEM subjects. So we really hope this will have impact. It already is having impact in the last few years that we have started it, and possibly we will expand it as interest grows. But it's important to have girls as well as boys active in engineering. Do you agree?
Absolutely. As a matter of fact, I wanted to touch upon also the kinds of facilities you have, let's say in the School of Computer Science and Engineering, side. First, so we have IoT labs, for example, we have AI labs, machine learning labs, we have networking or cloud computing lab. So advanced labs, in addition to your, your traditional programming, various programming labs, some 18 different labs we have just within the School of Computer Science and Engineering. And of course, we have some common resources that we have. For example, electronics or electrical, some of the services we get from your labs, as a matter of fact, for some of our work.
Absolutely.
And similarly, we provide from our AR, VR lab or IoT lab some of the needs that you may have, or the School of Design has, or School of Business has. We have that sort of a opportunities. Basically, it is telling you not only we have fantastic, like you mentioned, some of the best equipment, but also we allow a bigger platter of possibilities to our students, so they can work across and take advantage of, you
have some supercomputers, I believe.
Yes. So we have a computing center that has data centers and supercomputing workloads. So that is yet another facility, and we have a central computing center also, where anybody from any discipline can come and utilize as a university level facility. So yes, and coming back to your question of supporting our girl students, absolutely right. 20% scholarship right off the bat we provide, and there are other types of scholarships we give it to our scholars, and there are even some need-based offerings as well. And we are constantly trying to expand our our bouquet of assistantships and scholarships. As a matter of fact, we are in discussion at the high level even to provide some teaching assistantship and research assistantship to our graduate students, such as MTech, PhD, etc. So I absolutely. And I guess the next question we have covered.
Well, maybe one thing I forgot to mention, what to look for a college. Because engineering has so many disciplines, as I mentioned, it may in fact be difficult for aspiring engineering students to know which discipline to go to. So what I will sort of say, UPS has a common first year. So they join the engineering cohort, they do a common, they can explore, they can discuss things with faculty. Is mechanical engineering what they should be doing? Is electrical engineering what they should be doing, etc. So they have a whole year to investigate that and really what inspires them and what they want to do. And then from year 2, they then specialize in their chosen domain. So that could in fact be quite important for some students, because when they are coming straight from school, they don't really, I think, have the true idea of what engineering is about and what the possibilities are.
Right.
So I think that is important. So I forgot about that. So I thought.
No, absolutely. I can add to that. As a matter of fact, even in the School of Computer Sciences, we allow the first year students to do all sorts of basic and core courses and a little bit of exploratory courses, where they try to understand where their passion lies. And after that, for example, the School of Computer Sciences offers 16 specializations, a number of areas, cybersecurity, AI, data science, big data, even petroleum engineering analytics to complement, let's say, what petroleum engineering from the engineering perspective gives, they give from the computer science perspective. So many such, financial, in the financial domain, etc. And so that is fantastic. And talking about the computer science various opportunities, and you know about the digital transformation, right? World Economic Forum said that the digital transformation will bring $100 trillion worth of social and business value. Right. So it's social in which sense? Business value, everybody understands, company, jobs, whatever things we do. But social value by addressing the issues of carbon dioxide, that is, for the climate change. So fantastic reductions to the various optimizations and intelligence in from logistics to electricity generation domain to the various manufacturing and industrials, etc. They are getting transformed.
Right.
So truly our students have, a plethora of opportunities, and they are given those opportunities after, so to speak, pre-training or pre-educating them, which is valuable rather than forcing them into something, right off from their high school when they join the college. So I agree with you. This is truly a wonderful
absolutely.
setup.
Shall we move to the next?
Yes, please.
Let me. So I think the next one we pose, which might be interesting, is how does UPS differ from other colleges, and also maybe the vision ahead. So if you want to start from
Sure, I'll make a few points, and so there are a number of data points about the UPS, but I'll mention only a couple, not to sound very bombastic here. The UPS is considered the first core sector university in the Pan-Asian region. They have gotten a recognition for that. And they are also the first Indian energy university recognized by UGC.
Yes.
It's the first university in the world to offer co-branded BTech programs. For example, from my school, we co-design, co-deliver with the industry, such as IBM, many of our specialization courses. So industry is deeply embedded within the university in that sense. Typically a thing that is missed in many other programs and schools. So we kind of prepare our students. So that speaks for itself when their placement season comes in the final year, right? We have seen really 100% placement for our students who are eligible to take the placement. And I'm told some 7,000 alum from our university have been placed. Some 750 companies have taken both national and multinational, some numbers that have been given. So essentially we are making them both industry ready and ready for higher education. So I guess you may want to add a few more viewpoints.
I agree. It's been a forerunner in engineering education for many years already, from its starting point in the focused area. Now it's a truly multidisciplinary university. Now the plan in hiring me and you to UPS is to raise quality even higher in this area of technology. So from the engineering side, we want to raise the quality by clustering our different colleagues, by focusing on things which are very important to us here in Uttarakhand and in India. So we have this kind of agreed that we are living in a very dangerous part of India where there are a lot of disasters and so on with the Himalayas and raw nature, beauty, but raw nature. So we will be focusing on rural technologies, hazardous environments, and also healthcare, medical care technologies. And because of my area in robotics and your area of software, we want to see whether the robotics can be enabled in this area, and that is already started. We will be developing the latest technologies in very, very advanced levels of real-time control, which will be just words to our people from schools. But if they Google these things, what the fastest sensor actuator loop technologies used by the latest developing advanced countries in Europe and America and Japan, where robotics is being led, we will be adopting those kind of technologies and not the kind of the Arduino-based robotic DIY projects that I call them. We will be not doing them anymore. I feel that this is a tragedy that when you are taking an Arduino DIY project and then claiming that you have built a robot or something, and all you have done is You have downloaded a menu, followed the menu, and flashed some program onto the microcontroller and not understood anything. So we cannot continue this if we want India to become a truly technology-based country. The multidisciplinary comes back to that again. We must develop that, and we must grow that, and also the entrepreneurship, encouraging startups. We want to really do that. We want to teach our students about what is called technology readiness levels. So where is a particular technology? Is it just somebody's idea, or can it actually be used in a commercial company to make a product that somebody can buy? Now, there's a huge amount of difference, and so as a university, we already have an incubator base, and we want to really develop that and encourage that, and support our students to perhaps have ideas of having startups here at UPS once they have learned the skills that we have taught them. So these are things which we plan to do through the continuous training to the high technology. We will be doing that, and it has already started.
Right. As a matter of fact, we have an incubation center in the university. We call it Ucie.
We should wrap up, I think. Sorry.
So, as you mentioned, we within the School of Computer Sciences, we work on projects that are many times really hands-on, and it actually impacts the nation as a whole. We have been recognized by Project Tiger of India, because we did some project for saving and protecting the wildlife. We have a great relationship with the Wildlife Institute of India and other research institutes that are there. So already we are moving in the direction where students are not just doing theory in the class,
Correct.
you know, by rote learning.
No.
We are actually leading the charge or the vision of National Education Policy 2020,
Right.
as a matter of fact. So I'm pleased to say. So in the closing, I suppose we are coming to
I think we should close and allow some questions to be.
So in the closing, I would like to invite you to consider studying and doing research at UPS. And I would like to leave you with these thoughts. Expertise in computing enables you to solve complex and challenging problems. Computing offers great opportunity for true creativity and innovativeness. And UPS provides a great environment for higher studies, experience, and the future opportunities in computing and engineering are boundless.
Okay. Well, in my sort of summary, I would conclude with very similar comments, so I won't repeat them. But what I will say is, if you join us, you will be joining the family of UPS, and it will be a long, lifelong relationship. That's what we want. We will support you for your time here. We will support you when you leave, and we hope that you will have a really successful career as an engineer or as a computer scientist. And we look forward to now maybe trying to answer some questions.
Some of the questions, yes.
I see that several questions are there. So maybe one is, first question is, there are so many engineers who are unemployed or have been made very low profile jobs. So how do you address this kind of high level technology with very poor kind of opportunities, I guess is the kind of question.
Right.
Do you want to take that?
Sure. That is exactly why we are thinking about advanced engineering and advanced computer science,
Right.
or smart computer science. So when the education is not, you know, it's just doing a common denominator kind of a level of teaching and education and training, it's very hard to expect very high level jobs. But I'll tell you, one of my students just last year got a 45 lakh per annum offer. So, you know, so truly we can get some of the world's best jobs as well. But we are transforming our direction. Already we have the foundations in our university, I believe.
Yes. My take on this is a little bit checkered, I must say, because I was trying to hire people also. So this is a chicken and egg situation, in my opinion. I believe if the quality engineers are there and the quality jobs will then arise. I think in the first place, if we produce the quality engineers first, we may have to encourage them to have startups themselves. This might be an easier option. Or in fact, we will be training engineers for Germany or US or these countries where the jobs are already there. This would be, in my opinion, a tragedy. But of course, but here's a chicken and egg situation. The jobs are not there because the graduates are not there. And this is a vicious circle that we must break. So it's our intention to break this cycle by at least starting to produce the quality engineers and in the starting point, at least create jobs for them by the startup incubator. So I hope that answered the question.
Great. So I see some questions that could be best answered by you.
Okay.
So which type of engineering is most successful in current times when the world has been going through the pandemic?
Well, well, of course, the specialist areas that I mentioned, I think the three core areas are mechanical engineering, electrical engineering, and software engineering, or computer science. I always like to put the computer science engineering on the end of computer science, because engineering, I think, does add a distinctive real world situation, although we have some subtle differences in terms of, but let's not quibble about that. I would argue that if you are undecided, choosing one of these three, you cannot go wrong. Electrical in the wider sense, mechanical in the wider sense, and software computing in the wider sense are pretty much universal. You will have a job for life if you are good in any of these three areas. But you must be deep. You must be able to compete with the engineers at the international level.
Okay. So there is a general question before, and there are a few questions seems like could be addressed by me on machine learning and AI.
Okay. Why don't you take one of those?
But let me take that specific question. How is machine learning and artificial intelligence different? Okay.
Okay.
So,
interesting question.
A very interesting question.
Right.
So the simple way to define that, it's a little bit complex. The field of artificial intelligence has a long history. All the different disciplines are involved in the creation of the field of AI. So AI really refers to a much bigger umbrella. It is a collection of various technologies and disciplines and theories.
Right.
Whereas machine learning is a subset of AI.
Right.
Okay.
Right.
ML is a subset of AI. That is where how we use the current CPUs and GPUs to extract knowledge or intelligence from the data that is available, the globs of data, the tsunami of data that is available all around us. Those involve specific techniques and specific mathematics and algorithms for that. Some of you might be also wondering what is deep learning, what is machine learning. As a matter of fact, deep learning is a further subset of machine learning that really involves neural networks. So I'm sure much of this you will study if you take some of our classes. Now, and we can discuss further on that. So I'll.
There's a lot of questions. I'm not sure we're going to be able to answer all of them, but feel free to drop either me or Priyadarsan an email, and we'll go through every single one. But let me just go through some of them. There's a question about future of civil engineering. Well, civil engineering is probably the oldest and the most biggest engineering discipline. In any country you go, construction is the largest. So the future of building construction will be there, and not just building buildings, but roads, dams, all these kind of infrastructures need to be designed. And coupling it with the architecture, we are thinking of going in this kind of a direction and having architecture and civil engineering combined for the future. Do you want to take the social internship contribution?
Maybe I'll address a little bit later
Okay.
on the social
Okay.
internship, because it's common. We can
Yeah.
take on
Okay.
later.
Let's do that
I will
then.
rather
Which one?
let me take the question about the neurochips as well as cybersecurity
Okay.
and blockchain.
Okay.
So really, cybersecurity and blockchain, they're different specializations and they have different strengths and applications.
Okay.
So I would prefer one over the other from the career perspective, but cybersecurity is something right there. The needs are right there.
Okay.
Blockchain is an evolving, new, emerging area and emerging technology. So there would be a difference in terms of the number of jobs that are available.
Okay.
I don't mean to say one is better than the other or anything like that, but that is the truth. That is, cybersecurity would be generally available. I mean, needs employment opportunities would be there. Let me take the question about the neurochips. The question here on Facebook, question on Facebook from live. Oh, okay. Will AI be able to control our behavior? Interesting question. Like the concept of neurochips. So I come from the chip background. So two things I talk about sometimes when people, I teach architecture. One is the so-called neuromorphic computers or neuromorphic chips. And the other is quantum chips. Fortunately, I was not asked about quantum chips.
Right.
That is a whole another discussion we could have.
Right.
So it is all about neurochips or neuromorphic chips.
Right.
So, it is, at this moment, it is theories and speculations.
Right.
Actually, some people, very smart people, of course, have predicted that in about 50 years, there would be an inflection point where we call the point of singularity. Right. Where the machine intelligence will exceed the human intelligence. Right. That is to be seen. Take your pick. In terms of controlling our behavior, see, the machines are already indirectly controlling our behavior by observing us, by looking at our emotions, and we are already looking at our phones multiple times in every minute. So, in a way, they are already controlling, depending on how you define controlling is.
Correct.
But there are also some very important discoveries, inventions are happening around bio. See, traditionally, we have figured out how to operate a prosthetic element through messages that are coming from the brain, meaning that a human being is thinking, oh, I want to grasp this. And then the prosthetic closes on the object.
Correct.
But going forward, what will happen is that the message will be reversed. It can go back to the brain. That is, let's say you touch a piece of glass, or let's say a piece of metal. That feeling of what is humanity, that can be communicated to your brain, and then it's human. So truly, it's an astounding and fantastic world we are entering. Has its risks. Many risks of bias and fairness and various issues are there. That is for another time.
Well, you mentioned the project. Well, my company, as you know, is making these kind of things, designing them, the wearable exoskeletons. So these are Iron Man type suits which help people move. And I've done some work with the brain control interface that Priyadarsan has mentioned. These are truly wonderful areas, but the technology readiness level is a little bit low at the moment. So we have to think about what actually can be put into a product. And so there are other things. Let me take a question about how can robotics help landslides and other hazards in high terrain area. Well, they can. I was in fact involved in a robotic project about 10 years ago in Italy, in Sicily. It was to make a robot to explore Mount Etna while it was erupting. So robots, what robots allow us to do is it allows us to put sensors in very, very dangerous places, include like erupting volcanoes. So if some landslides are going to happen, you can take these sensors and deploy them there, and then those sensors can help you detect imminent danger like a landslide about to happen or so on, or through seismic activities and things like this. So it's all about deployment of sensors in hazardous environments, and robotics can definitely do that.
Okay.
There was
I will take, I think our questions are a little bit different. You are
but
getting.
let me give you one, because I think this is an important one.
Okay.
It's actually connecting schools to universities.
Okay.
What it's saying is, how can we change the scenario, because integrate new ideas at school so that the university linkage can be done better. So I think this is a very interesting
Very,
question.
very important. Actually, I have received that as well. I will briefly talk about it. So within the university, we have a mechanism, and that mechanism consists of three things. We have something called Department Consultative Committee, where I just held one couple of days ago, where the inputs are coming from our alum, the recent pass outs, for example, the current students in our school and other schools, like I had law school and school of business, for example, as reps in the DCC, and faculty and academics from outside. Okay. So we are actually studying our curriculum grid. What are the different majors and minors we are offering? What are specific courses we are offering? So that is happening twice a year. These revisions. Then beyond DCC, we have something called Board of Studies. I just invited one of the most senior professors from IIT Kharagpur and from Arizona State University in the US to join the Board of Studies, where again, various faculties and various student representations are taken in. We debate and discuss which courses to bring in, what works well with which year, and the course grid, etc. we determine. Then we take it to something called the Academic Council meeting, which is at the university level. People like you and me and a few other deans, they're all involved there. So we have an entire mechanism to do that, in addition to the fact that our professors and students, they have open ears and eyes. They're also hearing from others throughout the year to improve a particular course, for example, not to change the curriculum. The curriculum change has to pass through this mechanism that we have set up, the formal mechanism, but improving the course itself, for example, or modifying, adapting, whatever you will call, we have those outlets as well. You want to add anything to that?
I think you've answered the thing, but I think the only thing I would perhaps say, there definitely needs to be closer ties between schools and colleges and universities, and especially when the linkage with the technologies and STEM teaching, because I think more real world hands-on things can be done at school, in my opinion, which are really teaching the students something, not just soldering and something like that. So I think that I think I would encourage schools to do, so that they can start addressing the real world. So the agenda at schools probably do need to change.
That's right.
And not this copying.
Actually, this NEP
Google
2020
stuff is killing us.
Yeah.
Google search. So I would urge you, engineering cannot be learned by Google. I will implore all people who are listening, you cannot learn real world problem solving through Google, because this is not how you do it. And if you think you can do it by Googling, you are sorely mistaken. So you have to get your hands dirty. You have to learn the details.
So it can help you, but don't do copy and paste.
Don't do that.
It will take you nowhere.
Absolutely
essentially.
not.
Okay. I don't know how much time we have. We have adjusted our time.
So we probably better close. But if you guys like it, then we can repeat this. And,
I know there was another important question about the COVID, the pandemic response through our college, how we are teaching. Everything,
everything is online.
Online, and we have, in that sense, digitally transformed our university.
Following all protocols.
The COVID, the protocols, and how we teach, the smart boards, various
You've seen our masks
deployments
are just put over there because we want to show you our faces, not the masks. So we are... But all protocols are being followed.
So we would like to, both of us would like to thank you very much for all the time you have invested and listened to us. And we welcome any questions through
by email,
reaching out to our university interface people as well. And we hope that you will have a wonderful year and happy learning.
And stay safe. And we hope this interaction was interesting and useful for you. And hope you find a good course wherever you go. And happy careers, long life, and be safe. Thank you.